Today I'm going to talk about Java in relation to its family members of the JVM and how in the last years it started to pick up with the features that the other siblings had. Okay, so over time, Java got this, let's say, feeling from the programmers that it's like a father for the other languages like Clojure, Scala, Kotlin, Groovy, and that it kind of remained behind because Scala, Kotlin, and the others had fresh breath and new features, and they were developed fast. And Java, with its standardization and all the things that it's had to keep in place, remained like a legacy code. Well, today my purpose is to convince you that it's not like this. This image is, well, it's a nice touch from Teenage Mutant Ninja Turtles, but it doesn't fit with the image of Java and the others. And there are two projects at the base of the features that I'm going to describe today. The first project is called Project Amber. And this project is concerned with POJOS, like what we've seen as plain old Java.
Andrei, can you hear me? Because we cannot hear you for some reason.
The sound just stopped, I think, a couple of seconds ago.
Now it's better? It's better?
Oh, interesting. People in the audience are saying that they can hear Andrei. Okay, then
the microphone
we just cannot hear you. So, but if the audience can hear you, we'll fix our issue here. Okay.
Okay.
Let's continue.
Right. Okay, so it's concerned with plain old Java objects and also pattern matching, which I'm going to explain. Okay. Okay, so you know plain old Java objects, they're the hurdle that we had to go through every time we had to write a class that encapsulates data. And we had to write so much boilerplate if we wanted to make an immutable data objects. It was like write final fields and then write the constructor, how it assigns everything, the getters, and then okay, you maybe want to write an equal method if you need it in hash code, and then how it's represented to string. There are tools that make this for you, but it's not the most elegant way. So other languages like Scala and Kotlin came with some features, so it would make it more standard and also easier to write. So in Scala, we've got case classes. In the case class, you write the fields in it, and it's just like that. Boom, you've got the equals, hash code, you've got the getters and everything. And the same thing is with Kotlin, just here it's called data class, different flavor. And yeah, you also write what kind of values. And then in Project Amber started with JDK 15, they thought, well, we can do the same. It's not a big deal. It's syntactic sugar. So they added the concept of records, which is the same. You put the fields, and then it's going to write the constructor to string everything. And you've got the same feature like in Scala and in Kotlin. So pretty nice. First step in towards let's say 2020 something. Okay, but here we go into more interesting stuff. So pattern matching. You remember in old Java when we had to write switches. This is rather naive example, but let's consider that they're not string. Maybe they're enums, and you want to write a case. You had to insert breaks. The language didn't. When you switch something, it has to be the same type in the cases, so it's not very flexible. But Scala is way ahead. So when I first learned Scala, I was amazed by the power of pattern matching. You can, well, the first case is pretty simple. You've got cases that are with nor, and it's more concise. But then what you see in the second example is that in Scala, you can switch for in the same object for lists, for the components of a list. You can extract from them here. Yeah. So it's pretty powerful. You can put almost anything to switch for, and it's syntactic sugar in the back. I will also argue as part of this presentation that the improvements that Java makes are also going to benefit its siblings like Scala, because everything is transformed into bytecode from Scala. And if the JVM improves and makes things more efficient, then it's going to be an improvement for the others. Yeah, so to get towards what Scala makes with pattern matching, Project Amber has come a long way, and I'm going to take it step by step. In a first, so in JDK 14, in a first release, they added the concept of pattern matching in instance of. So you remember, if you have an if, in where you check if an object is an instance of a class, you had to do the cast here. It's one line of code that's extra, but now in JDK 14, you can write the name of the variable after the cast, after the class, and you don't have to write that extra line. It's a small, neat improvement, of a small first step. Then it went to switch, and in JDK 17, we've also got pattern matching for switch, just in a limited way at first. So if you want to check for class names in a switch, now you can write cases with the type and also the name of the variable as a handle. And very concise, you can switch and use based on the class name. Yeah, so pretty neat. And in JDK 18, they increased the expressiveness. So now it's just like boom. We don't only switch on classes, but we also have we can check for particular values, but also classes in the same switch, and we also can add guards. So this is a guarding condition here, integer, and then if the integer is greater than a particular value, so this is a Boolean expression. Yeah, and also nulls here, and yeah, it's not like we've seen in Scala, but it's a long way to, and it came a long way in JDK 18. Okay, and in a future JDK, we'll also have record patterns. This is part of what it's going on now in the Project Amber. So if we've got a record, and here's point. Previously, yeah, you couldn't do much with it, but now you've got, you can do instance of point, and then in the parentheses, you can specify the name of the parameters, and it's going to extract them, and you can just use them conveniently afterwards. Then also in switches, in cases, you can do the same and use them. I can't wait for this to come in the next SDK, because it's a lot more expressiveness. It's just it's going to deconstruct that point, which is something pretty new in Java. So that's why I think it takes more time to cook. Okay, we've seen what Project Ember is about. And now it's time to move on to the next project. This project Valhalla is a project concerned with data types. You know that in Java we've got primitive data types and composite data types, and there's not much, well, one cannot work with the other that seamless. We've got to do unboxing, boxing. Okay, that's seamless, but other things don't, like creating a list of primitives. Yeah, and you know the primitive types, they're the usual, not like in C++, they're, the number is less, but still enough to be able to model almost anything that we've worked with in Java. But anything else is derived from object, anything outside of this list, including byte, integer, so they're derived from object. And that poses a problem. And the way Scala and Kotlin went about this, they just said, well, don't be concerned about primitive types or composite types or boxed types. Just use one class, and the compiler is going to do the work for you. So the types are all derived from object, and the compiler is doing the improvements in the back. Same list of primitive types, only they're not so primitive. And now Java is kind of the responsible, the guys from OpenJDK are kind of responsible for making this more seamless in the back. Yeah, and as I've said, you cannot create lists of primitive types. It's going to create an error, while generic types, let's call them. And in Scala, there's no other way. It's just you're going to create the box types. And probably there are no improvements in the back. There's no support from the JVM. Okay, but let's think a bit about these questions. Why do we have primitive types in the first place in Java? Like why Java chose to have primitive types, and then Scala and Kotlin said, well, no, we'll do everything in the back. Also, can Java make it more seamless to work with those types? And can we have more primitive types like unsigned integers, geographical locations? We can consider those primitive types because they represent one value that's almost atomic value, like unsigned types. And to answer this, we've got to open the gates to Valhalla. This comes, well, everything is in preview now, and they're thinking about doing the following changes. First, we didn't have a class for the primitive types. That's a problem into making working with them more seamless, which they will first attempt to improve by giving a class to the primitive types. So you wouldn't do for a double, that's primitive get class, but they want to add this Q in the front, which signifies that this is a class of a primitive types. We work with it more carefully in the JVM. Yeah, and then to show you the next features, I want to talk first about class identity. I'd rather call it object identity. And what it means is that when an object has identity, it means that two instances of the same value are different. This doesn't happen to primitive types. Primitive types don't have identity. So an object that is equal to 2, like integer a equals to 2, is the same as b equals 2. So they're when you equal them, they're the same. They don't have identity. That's what guys from OpenJDK call identity. But yeah, I don't really agree with this name, but it's different in math. But let's use it like this. So objects that don't have identity, they're stored on the stack. That's really obvious. And objects that do have identity, like an object, they're stored on a heap. Okay, now that we know what identity is, we can talk about value objects. Value objects, or value classes, they don't have identity. So think about now that we're going into making objects as primitive types. That's what they're attempting to make. And first, they want to give the possibility of declaring objects that don't have identity. And so far, the definition of those objects is still being defined. But the rules that they came with so far is that the class should be implicitly final. The instance of the fields of the instance are implicitly final, and no constructor can call super. So you don't, even if you derive this from something, you cannot call it super constructor. Here on the left, you can see how it's declared, and you'll see why this is important in the next slide, but it can have cycles. So a value object can have references to another object of the same type. And the constructor and everything you can declare. In return, what do you get? Well, they're put on a stack. And they work more, the equality will hold between them, because it's even if they're different references, they're the same. They don't have an identity. They're the same object. And we're moving on to primitive classes. The name of primitive is now in them. Primitive class is like a value class, but with the additional restriction that no field can be of the declaring class. So we don't have cycles like we had previously. Yeah, and the rest is the same. In return, what do we get? We get performance of the same performance as primitive types in terms like the compiler. That's what they promise. And also they do not allow nulls. So you cannot equal to null an instance of this class. And yeah, you might say, yeah, it's not going to why not nulls? Why would this be a benefit? But those who had null pointer exceptions might think otherwise. Yeah. So yeah, and what's next in Project Valhalla? We talked about value types, and they also have some specialization for generics. and some enhanced features for volatiles, but these are not related to so much to the other languages, but there's something that's related to what we have in Kotlin. They say possibly only other related topics such as reified generics, but you'll see why what I present here is pretty much what goes towards reified generics. But let me talk about them, about reified generics a bit. This is a code from Kotlin. Maybe you remember that when you give a certain object of a generic type, the generics are lost at runtime. This holds for Java, but it also holds for the other languages because they use the same JVM. And you cannot handle the class of a parameter that is of a generic type. You've got the parameter, but the information of the class is lost, and so you cannot do .class. And Kotlin has a neat feature. Well, normally you would, if you want to go around this, you would also send the class as a separate parameter. And this is a key aspect that's used for the feature that I'm going to present. Yeah, you pass the class, but it's not elegant. You've got the object here, there, you've got why wouldn't you send the class of it? And they've got this neat feature called REIFIED. So if you declare a function inline, then you can have generic parameters as reified. So an inline function means that the function content is inline. So the call to the function is based with the function content. And when you write reified, then in the back, it's going to add an extra parameter, which is the class of t. And this way, then you don't have to write extra parameters. It's going to look nicer. It's a workaround at the end. Yeah, as I said, the content is inlined. And Scala works around this in a bit different way. So this is what you see here as a class tag. It's a curried call. So it's something that implicitly is passed. This word implicit means that when you call the function, there's also going to the result is also going to be called with something extra, and this is added automatically by the compiler. And this class tag is exactly what contains the class information here. You can use the class tag to get the runtime class and then again get its name. And the function calls are just the same as in Kotlin. Okay, so Java gets there. It's not like it's a legacy language. It's more like it's running in the marathon and its siblings helps it get to the end of it, or go on, let's say. We don't know if there's any end. But yeah, I hope with this presentation I've changed your opinion about Java, and it's not like a legacy language anymore. We've also got some final words. The standardization, as I've seen it over the years, is not easy. That's what allowed, so the fact that Scala, Java, Clojure, everything, they were a bit lighter in terms of standardization and backwards compatibility, allowed them to develop feature faster. But Java needs to, because it's widely used and it's in let's say the company's business to keep backwards compatibility and forward compatibility maybe. Standardization held it back, but I'm surprised how much work has been put into these projects. So even with these features, Java would evolve and get inspiration from the other languages. As I said in the middle of the presentation, improvements in the JVM also transform into improvements in the sibling languages. I can foresee after those features, when those features are released in the JVM, you will also see in future versions of Scala or of Kotlin improvements. We've improved by 20% this kind. Well, they're probably going to use improvements from the JVM. Yes, and also in what I've talked so far, I expect maybe some small changes for what you've seen so far. The things that were released stay like that, but things that are in preview may change in time. Full disclosure. All right, we get to questions now.
Thank you, Andrei. It's been really a great talk, and I think you're right. So there's a lot of inspiration from one language to another. I think it's your talk comes very well, continuing what we were discussing with Ben Evans in the beginning, and also the new OpenJDK projects come into play. So it's really exciting now. I did have a question. So there are these languages that are, well, let's say non-Java languages, and usually Java does work. It does the job. What would be the scenarios when you would consider using another language instead, or maybe on top of core Java stuff?
So to make sure I understood the question correctly, what would I choose if? What would I look for when choosing a language that's on top of the JVM?
Yeah, I mean, if you're gonna use, I don't know, Scala for a certain purpose, what would be the reasons why you would look at that? Same for.
Okay, so far I've worked with Scala and Kotlin and a bit of Groovy, and that's why I talk from expertise. But if, let's say, I do this exercise where I forget everything about what I've learned about Scala, Kotlin, or Groovy. Probably the first thing I would do is look for how big the community is, who maintains that language. Because if it's an enterprise project, maybe I want to not use a language that's going to be deprecated after 5 years. And then if all of these things are checked, of course, I would use something that I would be comfortable with. So far, I'm most comfortable with Scala. It's the language that I've learned. I had a learning curve, of course. It's not like when I've learned Java, because it's focused on functional programming. You have to know the JVM. Well, it helps a lot, but also these new ways of thinking that Scala encourages you to use are pretty in line with how the mind thinks. So Scala is like I'm writing from my mind what I want to it to behave like, and it's almost like seamless. What I write is doing. It's also pretty safe it's very checked by the compiler.
Right. So I can say that well, classic Java has a more, I don't know, rigid syntax, or
It's more verbose than in Scala, and I understand this. Usually if if the project, it depends on the project that's started. Maybe if we need to have a startup and there are plenty of programmers that know Java, but we've got to make the project be a success in a short amount of time, I would go with Java. I wouldn't start learning Scala.
Yeah, sometimes team composition does dictate these sort of things.
Mm-hmm. Yeah, and also in older projects that already use Java, probably rewriting it in Scala or in Kotlin, if it's a big monolith, maybe it's not always the best idea.
Indeed. And what about, because we were also talking earlier about the release schedule of Java and how do people use it. What's your experience with this? Do you stick with the long-term support versions or also migrate to the intermediate ones?
Long-term support would be my personal choice. I say this because upgrading to new versions of Java is never seamless. I know this from when I have upgraded Java from 1.7 to 1.8, and there were no breaking changes apparently, but in the runtime there were a lot of breaking changes, and code that's written badly can break on upgrades. Usually code that's behaving badly. Um, well, yeah, long-term service also because upgrades are costly. If you've got a lot of microservices, you need to check, upgrade, test, deploy every microservice. It's a work that adds to the everyday struggles. But if there's a case in which one feature in a new JDK helps a lot with something that we need to develop, then definitely upgrading to that JDK is a nice option.
Cool. And yeah, Florian is not here, but sometimes something that he always asks, and I'm gonna do it in his place, is how do you keep learning? Because I see, all right, a lot of knowledge about Java, and then you're experting with Scala and Kotlin, and probably also using them in projects. How do you keep up, and what's your drive, and what's your advice for others out there?
These all of these things in which I'm working in, they're not random things. They're closely tied together. If I was learning Python and Java at the same time, maybe that would take my entire time. But that's not what I'm trying to learn. A lot of times I'm trying to hit 7 birds with one stone, and also the data engineering spark. This is Scala, not surprisingly. I think working in one field that improves the other fields has been my orientation so far.
Brilliant. Thank you very much, Andrei. It's been great having you again. And
Thank you for having me as well.
Yeah, we'll definitely continue these conversations.